Hey everybody, this is Larry. This is day 13th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. We have 632, smallest range covering elements from K-list. Yeah, I hope you like all the buttons and all the... I like all the buttons. I don't know, whatever. I went 8 miles today and then I raced home to do the contest. I'm very tired in both dimensions, physically and mentally. The contest was kind of draining, and you can watch that later, I guess, after this video. So yeah, it is a little bit later. I'm trying to sneak this one in and see what's up. Okay, I am gonna... Yeah, let's actually read this. I have some tea on. I don't know if you can see it. I have some tea on me and I wanted to drink because I am just so dehydrated in general. But alright, so you have K list of sorted integers in non-decreasing order. Find the smallest range that includes at least one number from each of the K lists. Okay, so what does that mean? So, I see. So AB, we have the smallest range that includes at least one number from each list. Okay. Let me think about that for a second. Well, let me just hydrate for a second. I think the part that I'm a little confused about is that this is a hard problem, right? All the lists are going to be yeah, there are a lot of lists. In fact, there are 3,500 lists, so you have to be a little bit smarter. So my first idea is that we can do this in a kind of a naive way, right? So we have these things, right? And then now this spans. You could kind of do it like is it sliding window? But maybe, right? But you basically take the first element, so it's 0, 4, 5, right? And then now you 0, 4, 5. Now you have a range from 0 to 5 that spans all the range, so you're good. And then now the next is going to be 9, because we pop off the 0 in a sliding window kind of way. Because we have 0, 4, 5, you pop off the 0, you get the next number. It's a 9. The smallest number is now a 4, so you have 4, 5, 9, and well, the range is going to be 4 to 9, right? And you just kind of keep on repeating it that way, and that should kind of have a way of doing it. And of course, if you do it naively, K is too big for you to do it naively, but you are able to do this with a heap, so it's not that bad of a deal, right? And the other is 50 is fine. So you basically have a heap to kind of repeatedly get the smallest number, and that should be the general idea, I think. So yeah, so K is your length of nums in this one, right? I don't even know if we need it, but yeah. So yeah, and then maybe we have like an indexes thing is equal to 0 times K. I guess we did need it. That was pretty quick. And then we have a heap, right? And then now for I in range of K, we want to say H, or we want to put in the heap of H. We want to put in num sub I of 0, the first index. We want to put I so that we know what index it is. And then we also maybe indexes of I increment by 1. You can also set it to 1, but I like to kind of keep this in the delta kind of way, incremental kind of way, right? And then now, yeah, while length of H is equal to K, is that true? No, maybe not. I don't know. I'm trying to think. Maybe it's greater than 0. I don't know what happens at the end, actually. Because then you have 20, say you have 20, 22, 24, which is actually the answer. But then now you want to pop 20. Are you done at popping 20? I guess so, because if you don't pop 20 and you pop the 22 to get the 30, that only gives you a worse answer, right? So yeah, so then in this case, if this is equal to K, right? Then now we have a min heap, so the thing that it doesn't give us min. I think one more thing that I forgot to do is that we have to put in the max number inside, right? Or that we put inside, so we just have to keep track of it, which is like largest is equal to 0 maybe, and then largest is equal to max, largest num sub I of 0, right? Yeah, and then now we pop from the thing, we have x, and do we care about x? I don't know, but yeah, and x is the number that we pop, then we get the next biggest number, or the next number from the index, right? I actually kind of missed something, but that's fine for now. We'll fix it in a sec. Yeah, because we needed to stop the bottom. But then now we have num sub index of index c sub index is the number that we want to put in, right? And this is going to be on the index. So yeah, so we put it back in, right? And we have to do two things. We have to do index c sub index, we increment by 1. And then the other thing is we have to check whether this number is larger than largest, right? And then of course we have to keep track of the answer, which is what I said, forgot to do. We want to do the smallest, right? So we'll set out a sentinel to be a big number, and then actually even here, right, then we know what the largest number is, but what is the smallest number? Well, the smallest number is just the first thing on the heap, right? So h of 0 of the first thing, right? So then it's this number, so the largest minus this is going to be a candidate, so then we just check it against best. Here is the same thing. After we pop and we push, then we now have the thing of largest minus the smallest number, which is still this thing, and we should be good after this. Oh, I think there is well, it's gonna, you'll see that it'll fail because I forgot to do one thing, as I was saying, which is that well, one is that I did this out of order. That's not what I meant. But on the pushing part, we only push if this index is valid, right? So if index is greater than or equal to the len of num sub index, then we break, actually, which I guess technically it would happen anyway, so you could write it in anyway, but yeah, 4 is not right expected number. I messed up because I mean, this is a easy fix, right? At least an idea. Because now I'm returning the best answer, but not the actual range. So okay, so then largest is equal to right, and then start is equal to, I don't know, negative infinity as well. It doesn't matter. Maybe it should be just like a none, right? So then now we just track things the old-fashioned way. Does it have to be the smallest number that works? Smallest range, but. Okay, whatever. There's too much reading. So okay, so if this is less than, or yeah, if it's less than best, then best is equal to this thing, right? And then start is equal to the smaller number on the range. And then we do it again here. And then now we can just return start plus start, and then start plus largest. Maybe largest. Well, yeah, that should be right. I was going to say maybe largest plus 1, but I don't think that makes sense. Oh, well. Okay. I meant best. Because, I don't know, I'm just being dumb today. Oh, well. I got... Well, one thing was that I was like, oh, I didn't realize that, yeah. But how did I even get this? Oh, we could have negative numbers. Okay, I mean, I just didn't read it carefully enough. I mean, I did actually see this earlier, but then I just kind of didn't pay attention. So, because I start out largest as 0, so if you have negative ranges, then you know, this is not going to be right. So we can just set it as negative infinity. I just totally missed, or just missed that part, right? Oh, I mean, we can put it in before we test it. Yeah, there's just a lot of negative numbers. I just didn't consider it at all. So, yeah, I mean, that yeah, that feels like not in the spirit of things. But either way, like, yeah, so that's really basically it, right? It's just using a heap to keep track of, yeah, I don't know. It reminds me of basically of, you know, merge sorting from K-list is the idea. And the key part about this in a greedy / sliding window kind of way is the invariant, right? The loop invariance of every loop. And this is the loop that we care about. This is just to populate. After every iteration of this loop, heap contains every number, or heap contains a number from every list, right? And in that way, the smallest number is going to be, the smallest number is in the front, and the biggest number we keep track, of course. And that's the range of all the numbers that are inside that we care about. And as we slide, as we pop up the smallest to get the next number, which can also be in the middle, of course, then we're able to kind of like shrink and add at the same time. So that's really the idea, to kind of think about this and look at it. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye. I'm back. Yeah. I mean, I just wanted to add. I forgot to do the time complexity and stuff like this, so I just want to add that in. Look, as we said, I'm really tired today, so I forgot. But yeah, this is a lot of pushes, but n is you have to define n very precisely, right? Because n is the size of the input, and the size of the input does not mean the size of the array or the size of whatever, right? But let's say you have n, where n is the number of total elements in everything, but the heap only has at most k elements. So this is going to be n log k, where k is the number of lists, but n is the number of element, and this is this loop actually takes all of n times, where each element can be popped once or removed once, right? If you do that kind of amortized, it's not quite amortized, but that kind of analysis, then you'll see that this is going to be O of n, because each element can only be added and removed once. So this is O of n, and each of that we add and removal is a log k heap pop or push. So this is log k, right? So this is n log k time, O of n space due to the heap. And yeah, and now I'm done, I think. Thanks for watching. Let me know if you stayed till the second time, and I'll see y'all later. Bye-bye. Let me say my usual thing, because I'm just gonna thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye.